Let's test our harmless ransom note algorithm to make sure that it functions as it should. Down here, where we previously called our function, we will pass in some note text. And we will pass this long string in as our magazine text. Feel free to copy this text from the source code at the end of this section so you don't have to write it all out. If you look closely at both of these texts, you will realize that we should be able to create this ransom note from our magazine text. Let's run our algorithm to see if it works. Great, it does. Now, if we take out a word like secret, it should fail because we need both of the words secret to make our note. And it does fail. Good. If we put secret back in and instead take out the word note, this should fail as well. Good, it does. Our harmless ransom note algorithm is working just as it should. Also, I want to point out that our algorithm has a linear time complexity. We do have two loops in our function, but they are not nested, so our time complexity is not exponential. So what does our linear time complexity depend on? Well, the most important parts of our algorithm that determine its time complexity are the two loops. We have one loop here and one loop here. Both of these loops run in linear time complexity, or O of n in big O notation, since they are not nested inside of each other. So we would say that this algorithm runs in linear time complexity, or it has an O of n runtime. Now, if we want to get really specific about it, only this loop down here runs an O of n time complexity, because it loops through every word in our note array. So in this case, the n in O of n represents how many elements are in our note array. This loop up here runs in O of m time complexity because it loops through every element of our magazine array, which very likely will not be the same length as our note array. So both of these loops run in linear time complexity, but since they each loop through a different array, we use different variables, n and m, to describe their time complexity. So if we want to be very specific about the time complexity of this algorithm, we would say that it has O of n plus O of m time complexity, which can be simplified to O of n plus m time complexity. In the real world, you might see this type of time complexity referred to either as O of n plus m or O of n. Either way, it has a linear time complexity. And that is how the time complexity of this algorithm is determined.